We called this the podium test. What would it take for you personally to confidently stand up in front of an international audience and make that claim? And when you put it in that way, I think for a lot of scientists, the bar is really high. So of course there would be obvious things, a very clear signature of technology or a skeleton or something like that. But we think that a lot of the evidence that we might encounter first will be much more subtle. For example, chemical signs of life that have to be detected above a background of abiotic chemistry. And really what we see might depend a lot on where we look. On Mars, for example, the long history of exploration there gives us a lot of context for what we might find, but we're potentially talking about samples that are billions of years old in those cases. And on Earth, those kinds of samples, the evidence of life is often degraded and difficult to detect. On the ocean worlds of our outer solar system, so places like Jupiter's moon Europa and Saturn's moon Enceladus, there's the tantalizing possibility of extant life, meaning life that's still alive. But potentially we're talking about exceedingly small amounts of samples that would have to be analyzed with a relatively limited amount of instrumentation that can be carried from Earth billions of miles away. And then for exoplanets, these are planets beyond our own solar system, really what we're looking for there are very large magnitude signs of life that can be detectable through a telescope from many light years away. So changes like the oxygenation of Earth's atmosphere or changes in surface color. So any one of those things, if they rose to the suspicion of being evidence of life, would be really heavily scrutinized in a very sort of specific and custom way to that particular observation. But I think there are also some general principles that we can follow. And the first is just, are we sure we're seeing what we think we're seeing? Many of these environments are not very well known to us, and so we need to convince ourselves that we're actually seeing a clear signal that represents what we think it represents. Carl Sagan once said, life is the hypothesis of last resort, meaning that we ought to work hard for such a claim to rule out alternative possibilities. So what are those possibilities? One is contamination. The spacecraft and the instruments that we use to look for evidence of life are built in an environment, Earth, that is full of life. And so we need to convince ourselves that what we're seeing is not evidence of our own life, but evidence of indigenous life. If that's the case, we should ask, should life of the type we're seeing live there? And finally, we need to ask, is there any other way than life to make that thing? Any of the possible abiotic processes that we know, and even the ones that we don't know. And as you can imagine, that will be quite a challenge. Once we have a piece of evidence in hand that we really do think represents evidence of life, now we can begin to develop hypotheses. For example, do we have separate independent lines of evidence that corroborate what we've seen and increase our confidence of life? Ultimately, all of this has to be looked at hard by the entire scientific community. And in that sense, I think the really operative word in our question is we. What does it take to say we found evidence of life? Because really the answer, I think, depends on the full scientific community scrutinizing and skepticizing this observation to finally say that we, scientists, we as a community, and we as humanity found life.